So up until now, in Math 102 and Math 101, if we saw anything like this, we would write down non-real answer. Put in our calculator, we would get that the square root of any negative number was a domain error, that square roots couldn't be negative. However, in this section and the next, we are going to be using this idea of imaginary numbers. So imaginary numbers are any number that contain the square root of -1. Someone a long time ago decided that they were going to define the square root of -1 to be this variable, if you will, I. So I stands for imaginary, and it is any time you see a square root of a negative number, you're going to have an I in the answer. So now, instead of writing non-real answer for things like this, we will have I's involved. And so let's see exactly how the I's will come into play. So in this first example, this one is actually from your notes. I have the square root of -25. So I can write that as the square root of -1 times 25. Because -1 and 25 are the same thing. I mean, -1 times 25 is the same thing as -25. Then I can use that property from section 9.1, and I can split up the radical. Now the square root of -1, that's I, and the square root of 25 is 5. So just like x's, i's work very similar in terms of how you write them and how you combine them and all that. So I wouldn't write x times 5. I would write it as 5x. So I'm going to do the same thing with the I. So the first one, I'll have 5i. That would be your final answer. Now the second one, the square root of -45, I'm going to rewrite it as -1 times 45, and then split up the radical. Now the square root of -1, it's I. Square root of 45 isn't a perfect square, so I'm going to have to do my factor tree. So I'll break it up into 9 and 5, 3 and 3. I have 1 3 coming out and a 5 left behind. Now, just like before I wrote it as 5i, looks a little different, but I'm going to write the whole part, the numbers, if you will, in front of the I. So I'll have 3 square root of 5i. Make sure when you're typing that into Hawks, make sure that you push the over arrow key so that you get out of the radical. Don't put I under the radical with the 5. That's the 3 times the square root of 5, and then I is way outside, not under the radical house. So that would be your final answer. Now this is not necessarily, you don't have to go through all of this work. Once you get used to this idea, you see a negative sign under a radical, you can kind of think about it as coming out and turning into an I. So comes out, turns into an I. Alright, second example, subtraction. Subtraction works the same as subtracting polynomials. One thing that you should know is that we have this thing called standard form. Standard form means that you put the real number in front and then you put the i's in back. That's what a plus bi means. So I'm going to first have to distribute the negative. Now that I've distributed the negative, I can combine up like terms, just like if they were x's. So my first like term, 7 minus 1, or 7 plus -1, is going to give me 6. And then the second like term, I'm going to have 5 minus 1i is going to give me positive 4i. Now that thing is in standard form because I have a plus bi. So some of them in the homework will ask you to identify the real part and imaginary. So in this case, the real part would be 6 because it's the number that doesn't have an I, and the imaginary part would be 4 because it's the number that's associated with the I. Now notice I didn't write 4I as the imaginary. The imaginary part is just whatever is in front of the I, and the real part is the number that's way in front that doesn't have an I attached. Last example, I'd ask you to solve for x and y. So a little crazy, but if you know that real equals real and imaginary have to equal imaginary, and there's a fancy property that says that. However, what we care is we're going to take the two real pieces, set them equal, so the parts that don't contain I, and we're going to take the parts that do contain I and set the things in front equal to each other. So the real part here is 14x because I don't see an I. And the real part here is 18 over 5. So I'm going to have 14x equals 18 over 5. So now I'm going to solve this. So I'll divide by 14, and get x equals it looks like I got 0.25714. Hawks will probably say to 4 decimals, so x equals 0.2571. So there's my x. To find y, you set the imaginary's part equal. And again, the imaginary part is everything in front of the I. So I have the square root of 5 equals 5y. So I'm going to divide by 5, and get, I could leave it as that, or I could get the decimal equivalency, which would be, I got 0.4472. So that's how you find x and y. You set the reals equal to the reals and the imaginaries equal to the imaginaries.